Example 5.7. This is, if we solve the entire beam, this is 4 by 4. There are 4 degrees of freedom, one at A, one at B, rotation, rotation, then rotation and deflection at C. So 4. But we already know how to use solve this with the limitation of our calculator. So let's reduce this to 2 by 2. Let's only consider AB, and of course there's a moment at BC which is counterclockwise, which is 40. So in order to have nodal loads at B or at 2. So fixed force or fixed moment, reaction, fixed force also at B. And we have here 40 kilonewton. So since AB is, the loading is triangular, we have a formula for that available. For fixed moment A, it is WL square over 20. So consider only AB. So fixed moment AB is 12.6 square over 20. That's 21.6 kilonewton meter. At BA, 12.6 square over 30. So that's 14.4 kilonewton meter. F summation moment E equals 0. So FA times 6 plus 14.4 equals 21.6 plus 1 half of 6 times 12 times 4. Moment arm is 4. So FA is 25.2 kilonewton meter. FBL plus 25.2 equals 1 half of 6 times 12. So you'll get FBL equals 10.8 kilonewtons. Then for nodal loads or nodal forces, we have, since this is counterclockwise, it is clockwise, 21.6 clockwise at 1. At 2, only 40.4 minus 40, so that's negative, so it means clockwise again. And 25.6, 21, 14.4 minus 40 is negative 25.6, so negative means clockwise, so that's why we have clockwise there. For the stiffness of AB, we have 12 over 6 cube, and we already have this, so you can copy immediately as long as the first entry is 1 over 80. We eliminate rows and columns associated with zero displacements, which are at U1 and U3. So we eliminate columns 1 and 3, leaving this 2 by 2 matrix only. To solve for U2, U4, it is the product of the inverse of this matrix and this force matrix here. So without further explanation of the details of the calculations, because you already experienced the same calculations, so you get U2, U4 equals negative 17.6 over EI and negative 29.6 over EI, which corresponds to theta A and theta B. Now that we have found theta A and theta B, we need to consider BC alone. So at BC, there's no fixed end moments because the load is acting at the fixed end, because we imagine C as fixed. So C is fixed, C is fixed, B is fixed, C is fixed. So FDR is 0, moment DR is 0, moment ED is CD is 0. So summation forces Y FCL is equal to 20. So if FCL is 20 upward, then the nodal load is 20 downward. So that's the only load. So FDR is 0 and FCL is 20 kilonewton. So for DE, these are the forces. FDR 0. This corresponds to MBR, which is 0. This corresponds to FCL, opposite of FCL, negative 20. And this corresponds to MCL, which is 0. Then, because 12 over 2 cube is 1.5 or 3 halves, and we already have the same stiffness in the preceding problems, 1.5 and 5, and so on and so forth. So you for my case, I just copy it. Then the only node that has displacement is theta b or u4. So this is u4, that's u3. So again, we expand rows 5 and 6 for any two rows to solve for u5 and u6. So we have negative 20, 0 equals this matrix here times 0, negative 29.6. Then this matrix here, 2 by 2 times u5, u6. So simplifying, negative 20 minus quantity negative 1.5 times 0 minus quantity negative 1.5 times negative 29.6 would be the value there. And for the second is 0 minus 1.5 times 0 plus 1 minus 1 times negative 29.6. So 29.6 will be the value of the second. The first row it's negative 64.4, and we copy this matrix here. Since this is 2 by 2, we solve directly u5 and u6, which corresponds to delta c and theta c. So negative 112.533 over EI and negative 69.6 over EI, delta C, theta C. For the member forces, member AB, let's copy the stiffness. Then the displacements would be at 2 and 4 only, U1 and U3, 0. So we shade columns 1 and 3. And the fixed forces, FA 25.2, FBL 10.8, moment AB is 21.6 counterclockwise, moment BA is 14.4 but clockwise, so that's why it's negative here. And since we already experienced calculation matrix multiplication, the same, so 16 times negative 17.6 plus 16 times negative 29.6 plus 25.2, we get 17.333. You do the rest, and these are the member forces, final member forces. For BC, so shear BR, instead of P3, P4, P5, P6, I write the correct and proper designation of the forces. Stiffness of BC, just copy this. And displacements, we have 4, 5, 6 displacements, only 1 is 0, so the column 3 is shaded. Then fixed forces, BC, the only fixed force present is FCL, and it is equal to 20. This is here, all the rest zeros. So 1.5 times negative 29.6 plus negative 1.5 times negative 29 points, negative 112.53333 plus 1.5 times negative 69.6 equals 20. So that's the value. And you verify the rest, so it's correct because we expect zero displacement, zero shear and zero moment at the end. And of course, we expect moment BC to be negative 40, like that.